everyone. So welcome to today's lecture. We're on lecture 5, and this is just an introduction on binary operations. So I'm going to introduce binary operations, and then apart from that, I'll also do 1 or 2 questions involving binary operations, the calculations involving binary operations. Okay, so first of all, you need to know what binary operations are. So when you talk about operations in mathematics, we're simply referring to additions, subtractions, multiplication, and division. So those are the most important operations that we know. But there are also operations like union, intersection, set difference, all those. They are very important operations. Okay. So, but our main focus will be on the 4 addition, subtraction, and multiplication and division. So that's going to be our main focus on binary operations. So a binary operation is simply just the simplest definition of binary operation is simply just it's simply just a operation which takes an element from any given set and then operates on them, then afterwards puts the element back into the set. In other words, it's for instance, if you've been given a set of natural numbers and then they ask you to say, is addition a binary operation on the set of natural numbers? This simply means that they are asking you to say, if you get any 2 natural numbers, you add them, is the result that you are going to get a natural number? If the answer is yes, then addition is a binary operation on the set of natural numbers. So that's what it means. So let's quickly move on. So the other thing we have, symbolically, we can represent this statement here. So this statement says, let S be a non-empty set. So S is a non-empty set, and an operation star which takes an element from S and operates on them and puts the results back into S is called the binary operation of S. Okay, so this is what I just talked about. So using symbols, you can write S. You can write this star as S. This is an operation there, and then this is an operation there. You take 2 elements from S, element 1 and element 2, and then you operate on them. After operating on them, if the answer that you get is also a member of set S, then that given operation is a binary operation. So, for example, that is A and B are members of S. So A star B should give you the answer that is a member of S. So in other words, if you have a natural number, I gave an example of a natural number to say, if you have a natural number and then they say, is addition a binary operation on the set of natural numbers? If that's the question, it means that you have to find or you have to try any 2 numbers from any 2 or 3 numbers from the set of natural numbers. See if after adding those numbers, the answer that you get will be a natural number. If you find that the answer that you get after adding 2 natural numbers is a natural number, that simply tells us to say addition is a binary operation of natural numbers. But you find that maybe there's a set of 2 numbers that you can add, and then after adding those 2 natural numbers, the answer that you are getting is not a natural number. That can imply that addition is not a binary operation on that given set. Okay, so star is a binary operation on S if the result remains in S. So I've explained this. So the order of operating on elements may be important. That is, if A and B are members of set S, then it is possible that A star B sometimes may not be equal to B star A. So that is called the commutative law. So this part is called the what I've told us here, what the statement means here. It's talking about the commutative law. So the commutative law, let me explain it in advance so that when we meet it as we proceed, it's not a new concept. So the commutative law deals with the arrangement, meaning if you have 2 plus 3, the answer gives us 5. Then when you change the arrangement, you have 3 plus 2. If the answer still gives us 5, then addition obeys the commutative law. So this operation addition obeys the commutative law. So when you say, for instance, 2 minus 3 and the answer is -1, and then 3 minus 2, the answer is 1. When you look at these two numbers, the answers are different. The answers are different. So since the answers are different, it means that subtraction is subtraction does not obey the commutative law. So that's what it means. When you try 2 times 3 and 3 times 2. So here you also get the same answers. Here you get 6, even there you get 6. So this implies that multiplication obeys the commutative law. Now let's try to use maybe 4. Let's try to do division. 4 divided by 2, the answer gives us 2. And then 2 divided by 4, the answer is simply just 1/2. So when you look at these two answers, these are two different answers. Hence, division does not obey the commutative law. Okay, so the operation must be defined for every pair of A and B, where A and B are elements of set S. So here that was supposed to be S. Okay, so let's look at this example. They're giving us this set to say let set S be a set of natural numbers. And then they're asking us to say, let star be equal to addition. Let star be equal to addition. Then star is a binary operation. Since if A and B are members of S, then A star B, which is equal to A plus B, is a natural number. So if you get any natural number, any two natural numbers from this set, you add them. If the answer that you get is a natural number, then star is a binary operation on the set of natural numbers. That's what they just mean here. So we try to do multiplication. If you multiply two numbers, you discover that the answer that you get will always be, if you multiply two natural numbers, the answer that you get will be a natural number. Hence, multiplication is also a binary operation on the set of natural numbers. But let's also look at subtraction. Subtraction is not a binary operation because when you subtract a bigger number, let's say for instance you subtract 2 minus 7, the answer will be -5. So if the answer is if this answer is not not a natural number, because we're dealing with a set of natural numbers. So if this answer is not a natural number, it simply means that subtraction is not a binary operation on the set of natural numbers, because there are numbers that you can subtract in a set of natural numbers and you get the answer that is an integer, which is not a natural number. Yeah, so that's what it means. So hence subtraction is not a binary operation on S. Same applies to division. Division is also not a binary operation on S. Okay, let star be defined as S star B is equal to A minus B. So if that is your star, A star B, it has been defined by that. The magnitude of A minus B is equal to, the magnitude of A minus B is a binary operation on S, because after subtracting two numbers in between there, the answer that you get will still be positive, because we know to say, if for instance you get the answer as -5, the absolute value of -5 is equal to 5. The absolute value of 5, the answer will still be 5. So what this means is that if you have the absolute value symbols outside the operation minus, the answer that you get can fall into the set of natural numbers. Alright, so let's quickly proceed. So we look at the characteristics of binary operations. So I've talked about commutative law, which is just the arrangement where you say A plus B is equal to B plus A. So when you change the arrangement and the answers that you get are the same, it means that that given operation obeys the commutative law. For instance, if you have 2 plus 5, the answer is 7, and then you have 5 plus 2, the answer will still be 7. So addition obeys the commutative law. You can also try to do division, multiplication, and subtraction. Okay. So when you add two numbers in a certain arrangement, then you try to change the arrangement, you still get the same answer. Means that that given operation you're working with is commutative, or it obeys the commutative law. And then let's talk about the associative law. So the associative deals with the arrangement of brackets. So you can have A plus B, then plus C. So if you find that this is equal to A plus B plus C, if the answers that you are getting after solving this are the same, it means that addition obeys the associative law. So in the operation form, you can just write this as A, and then star represents, star can be any operation, and then if this is equal to this is equal to this, oh sorry, not this, so we say so this will be, the brackets will be on B and C now. Okay, so if these two are equal, this one and this one, you will first test the left hand side, you also test the right hand side. If you find the same answers, then that given operation obeys the the associative law. Okay, so that's what it means when we talk about the associative law. So let's look at the inverse and the identity element. So let's take, for instance, you have 2. If 2 is a number that has been given, and then we notice that the inverse of 2 is 1 over 2. So when you multiply any number with its inverse, the answer that you get is simply just 1. So this one in mathematics is called an identity element. So this is an identity element. And then this one here is called an inverse. So what happens if you multiply the element 2 with its identity element? So if you multiply 2 times its identity element, which is 1, the answer that you get will still be 2, still be that same element. So if we put this now in symbolic form, we say let the identity element of any given element be E. So if this E star A, so when we operate E and A, or we don't know the operation that is there, it can be addition, division, multiplication, whatever it is. So after finding E star A, the answer that we can get, that we're supposed to get here, the identity element times the element itself. The answer that you get is that same element. So this is just the same as A star E. So it doesn't matter, when you change one, you put it this side, the answer will still be 2. This is what I mean. This side or this side, the answer will still give you A. Okay, so from there, this is what you use. I can say this is what you use to find the inverse. So any given set that does not have an identity element, it means that it also doesn't have the inverse. That's what it means. It also doesn't have the inverse. If it doesn't have the identity element, then it also doesn't have the inverse. Now, how do you find the inverse? So let's say B becomes A inverse. So if A inverse is equal to B, it means that if you multiply, remember what I said here, the inverse with this element. So if our element is A, and then you multiply this, or if you say star the inverse. So if A inverse is equal to B, so we say if we find A star B, the answer that we're supposed to get is an identity element. This is what I wrote here. When you get an element 2, multiply it with its inverse, the answer that you get is the identity element. This is what it means. So this can also be written as B star A. The answer should still give you an identity element. This is what these two last points mean. So I've explained the last 2 points. So let's move on. So let's look at this example here. You've been given to say let star be multiplication. So if star is multiplication and the set that has been given is the set of integers ranging from negative infinity to positive infinity. The first question is star a binary operation? So how do you tell if whether star is a binary operation? What is our star? Our star is simply just multiplication here. So since multiplication is our operation that we are testing in this case, we can try to see if at all it's possible for us to multiply 2 integers and find the answer that is not an integer. If there's no possibility, like in our case, there's no probability of you multiplying 2 integers to get something that is not an integer. The probability is equal to 0. Hence, star is a binary operation on R. So we say yes. So star, the question is star a binary operation on the set of integers, not R, sorry. In the set of integers, the answer is yes. So the other question is star commutative? So let us try to get a star. So we have A star B. So A star B is simply just the same as A times B in our case, because we know that we are dealing with multiplication. So A star B is just the same as A times B. So we're trying to test if A times B is going to be equal to. So in other words, we're trying to test that if A times B will give us B times A. So from this set of integers, is A times B going to give us B times A, sorry. Let's try to get 2 numbers from the set of integers. So these 2 numbers we're going to get are simply just I don't know why this is coming. Okay. So the 2 numbers that we're going to get, let's try to pick 2 numbers. Let's take, for instance, we pick I said A times B. Let's take, for instance, we pick 2 and 3. So I said 2 times 3, the answer is 6. And what is 3 times 2? The answer will still be 6. Since we've found that A times B is equal to B times A, which was 2 times 3, we said is equal to 3 times 2, which simply just gave us 6. This implies that multiplication or star is commutative. That's what it means. Okay. So from there, Let us also now look at the last part here. Is star associative? Let's try to check if it's associative. So you take again three numbers. We can take any three numbers from the set of integers. So you can take so in short, when testing for associative, we're trying to test that a times b times c is equal to a times b times c. So we can pick three numbers. So we can say, we take first the left hand side. So the left hand side is simply just a times b times c. So a times b times c, let's take three numbers. We take 2 times 3 times 4. We see if we're going to get the same answer. So we first start with what is in the brackets. 2 times 3, the answer is 6, times 4, this 4. So this gives us 24 as the answer. Let's see if also on the right hand side we'll get the same. So on the right hand side we're dealing with a times b times c. So our a in this case, we get the same numbers there. We have 2 times 3 times 4. So we start with what is in the bracket. So we have 2 times 3 times 4, that's 12. So 2 times 12 there, you get 24. Hence, the given operation, which is multiplication, is associative. Hence, star is associative. So that's what it means. Since we found the same answer this side and the other side, hence star is associative. So if you don't want to use numbers, we can use letters, where you just say, okay. So for letters, you just make sure that the left hand side is equal to the right hand side. So when you multiply a times b times c, the answer will just be a, b, c. Even this side, a times b times c, the answer will still just be a, b, c. So since the left hand side is equal to the right hand side, this implies that star is associative. That's what it means. Okay, let's quickly move on. Okay, so this is how you can prove for associative using numbers. Yeah, so if you are using division, this question does not have a question. I forgot to put a question. Yeah, so this is just how you can use numbers in short. I'll show you on the question. There's a question up front there. I'll show you. So let's look at the tables here. How can you analyze tables on binary operations? So you have the first table there. Okay, before we look at the tables, let's look at the question. Let S, which is the set S, be equal to -1, 0, 1. So these are independent elements. Yeah. So they are not. This is not an interval. It's not a range. These are just independent intervals. And define the operation by the tables given. So these are the tables that have been given. The first question is determine whether star 1 and star 2 are binary operations on S. So how do you determine whether star 1 is a binary operation on S? Try to check the results. So these are the entries, or rather the elements that you have in the set. Now after working on these elements, the possible outcomes are simply just these here. So if these possible outcomes that we have there, if we have any possible if we have any outcome there which is not in the set there, we can say star 1 is not a binary operation. But if we look at 1, -1, -1, 0, they are all part of this set. Hence, star 1 is a binary operation on R. Is a binary operation on R. Sorry, on R. So it's supposed to be on S, not R. So it's a binary operation on S, on the set S. So we also do the same. These are the inputs. Then the possible outcomes for this set are these. So when you look at these, as long as they are all in that set, it means that Star 2 is also, it means that star 2 is also a binary. It's also a binary operation. So star 1, we said it's a binary operation. Is a binary operation. Then the second question is determine which of the two is commutative. So how can you know that this one is commutative, this one is not commutative? You look at the outcomes, in short, the outputs. So when you check the input, there we have -1 star -1, the answer is 1. 0 star 0, the answer is 0. The 1 star 1, the answer is 1. You also change -1 star 0, the answer -1 star 0, the answer is 0. And then let's also look at 0 star -1, the answer is 1. So there's this difference, right? -1 star 0, the answer is 0. So we see -1 star 0, the answer is 0. Then we also have 0 star -1. We know that commutative deals with the arrangement. So if we change the arrangement, the answer here will be 0 star -1. The answer is giving us -1. So the answers this side are different. Hence, star 1 is not commutative, or it does not obey the commutative law. Let's now check star 2. So star 2, we have -1 star -1, the answer is -1. 0 star 0, -1 star 0, the answer is 0. 0 star -1, the answer is still 0. Yeah, so -1 star 0, -1 star 0, the answer is, so we say -1 star 0, the answer is 0. Then 0 star -1, the answer is, so 0 star -1, the answer is 0. The answer is still 0. So there is consistency here. We can see that all the outcomes after interchanging the numbers are simply just, so you can try all these numbers in the box if you want to prove that. If they are all giving you the same answers, when you start from this side, going this side, if you're getting the same answers as starting from this side, coming to this side, then that given box or that given table is simply commutative, or rather star 2 is commutative. That's what it means, or it obeys the commutative law. Let's move on. So let's look at this last example here. The operation on the set of real numbers R is defined by A star B is equal to A squared minus 2, plus B squared minus 2, where A and B are members of R. The first question is star a binary operation on R? So is there a probability of you getting two real numbers? When you get two real numbers, you plug them in this expression and the answer that you get is not a real number. So the question is no, because we defined a real number as a set of irrational numbers and irrational numbers. So if there is a way you can put real numbers, any two real numbers, where there's A and B, you put any two real numbers there to prove, or rather to see if at all you can get anything that can not be a real number. So just by looking at that, just by inspection, you can tell that there's no probability of you getting a number that is imaginary, because apart from real numbers, the other numbers that you have are imaginary numbers. So there's no probability of you getting an imaginary number after putting in a real number in that expression. Hence, star is a binary operation on R. Or you can just say yes, because the question is star a binary operation on R? Just say yes. And then the next question here is star commutative. So for this one, you can either use numbers. You just pick any two numbers from the set of real numbers, and then try to solve the question both on the left and on the right. So we know that for commutative, A star B should equal B star A. So let's find A star B in this expression. So A star B is simply just the same, A squared plus B squared minus 2. So let us find B star A. While there is this A, we put B. While there is B, we put A. So we'll still have the same thing. So if you have the same thing, this implies that, this implies that the expression that you've been given there is commutative. Yeah, so because this expression here is exactly the same as that. Yeah, so it's just commutative. Yeah, it's commutative. Okay, so we move on to this one. Determine whether star is associative. So for associative law, we know that we have to test that A star B star C is equal to A B C is equal to this. So this applies for associative. So the first part here, so the first part is the left hand side. So for the left hand side, we're dealing with A star B star C. So this is the left hand side. So the A star B, we already have A star B. So A star B is simply just what you've been given there. So when you write it in this format, this whole expression here becomes my A, this one becomes my B. So we replace them back into that equation. We're going to have A squared plus B squared minus 2 squared, then plus C squared minus 2. So this is our first simplified expression of the left hand side. Let us also now look at the right hand side. For the right hand side, we're dealing with A star B star C. This is for the right hand side. So we first deal with what is in the brackets there. So what is in the brackets there, we have, so let me write my A there first, star, and then what we have in the brackets, but where there is A we put B, where there is B we put C. So we're going to have B squared plus C squared minus 2. This is what we're going to have. And then yeah, so from there this one becomes my A, this one becomes my B. So in that same expression, my A will still remain A squared, and then my B is simply just B squared plus C squared minus 2, then C squared minus 2. So when you look at this expression, is it the same as that expression even if we were to simplify them? The answer is no. And if the answer is no, and since the answer is no, then star is not associative. That's what it means. So let's quickly move on to the last part of this equation. Of this question. So from this same A star B being equal to A squared plus B squared minus 2. So in this same expression, they want us to find this. So our first value of A will be that, and B will be that. So we're going to have 3 squared plus 2 squared minus 2. Then after doing this, we have star 5 outside there. So 3 squared, the answer is 9. 2 squared, the answer is 4. Minus 2 squared star 5. So I have 9 minus 2 plus 4, or you say 9 plus 4. The answer is 13 minus 2, the answer is 11. So 11 squared star 5. So 11 squared simply just gives us 121. Sorry, 121. So after getting that 121, we have star 5 this side. Oh, I'm sorry, this is not supposed to be like this. This is just supposed to be 11. I thought I'm having this as my error. So this is just supposed to be 11. So we're going to have 11 star 5. So 11 star 5 is simply just going to give you, so while it's A, we put 11. So this will be 11 squared plus, and while this B, we put 5. So we're going to have plus 5 squared minus 2 there. So we are going to have 121 plus 25 minus 2. So this will give you 146. So 121 plus 25, this is 146 minus 2, which gives us 144. So this is how you simply just solve such questions. So thank you very much. This is the end of the lecture. Let's meet in the next lecture that we're going to have. See you. Shalom, shalom.